All right. So what we're going to do today is we're going to look at transformation of functions. So we're going to use vertical, horizontal shifts, reflections, and we're going to look at making them wider and narrower, so changing the shape. The original function is f of x. Those are those parent functions. The y equals x squared. The y equals x cubed. Y equals absolute value of x. Y equals the square root of x. Y equals 1 over x. I'm not putting the y equals x here, because are we going to shift y equals x? No, we're just going to use our slope-intercept form and graph them. So those are our parent functions. And then what does a plus c, like x squared plus 5, what does that plus c do to the original graph? It's a vertical shift, which means it's moving up 5. So it's a vertical shift of c units upward. If it's minus c, like x squared minus 5, x cubed minus 3, absolute value of x, and then outside that minus 3, what does that do? It's a vertical shift of c units down. C is downward, so that's down c units. Then f of the quantity x minus c, that means, let's say like x minus 2 quantity squared. And that is a horizontal shift of c units to the right. And if it's something like x plus 3 cubed, that's c units to the left. Questions there? All right, example 1. Use the graph of y equals x cubed to sketch these graphs. I'm going to put the parent graph first. That's at 0, 0, 1, 1, 1, negative 1. I'm going to dot it in. That's what the parent graph looks like. Then what does the plus 2 do to that graph? Moves it up 2. So each one of these points are going to be moved up 2. What you can do is move like the vertex or that middle, whatever point was on the origin, move it up 2, and then from that point you graph like you would normally graph. Over 1, up 1, to the left, 1, down 1, and then sketch it. Questions on that one? This one I added two changes. The plus 3 does what to it? Left 3 and down 2. So if I start at 0, 0, I go left 3, down 2. And I can just go up 1 over 1, left 1, down 1. I'm looking for rough sketches. I'm not looking for exact. When I graph this, I'll look to make sure you have those 3 points. Say that again.
Do you want to make the parent function in that, or just the parent, or just the function?
You can do just the functions. Some of us, it might help us if we do the parent function like I did. If not, you don't have to. If you do the parent function, please do it as a dotted line, so I know that that's the one that can tell the difference. All right. Then we have reflections. F of x, that's the original function. Those are the parent graphs. If it is something like y equals negative square root of x, it's reflected over the x-axis. And then if it's inside the function like this, it's reflected over the y-axis. Well, we would have to put in what values? We would have to put negative numbers in. So we could do 0. We'd have to do negative 1, negative 4. Okay. All right, negative x squared. Well, the original function is this. What does that negative in front do to it? Flips it over the x-axis, so it's just a mirror. So it looks like that. Negative inside flips it over the y-axis. So it just gets reflected. And this is kind of what we were just saying with Kahari, was I could no longer plug in positive values. I have to plug in negative values. I plug in negative 1, negative 4. What's the domain of the negative square root x? X is greater than or equal to 0. What's the domain for b? X is what? Less than or equal to 0. Thank you. Questions on square roots? Last one. What's going on here with this graph? What does the plus 5 do to the original function? It's left 5. What does this number, this negative out in front, do? It reflects over the x. Reflect first, then shift. Do your reflections first, then shift. So if I reflect, I'm right here, and then I shift left. 1, 2, 3, 4, 5. What's this domain? X is greater than or equal to -5. If you can't see it in the graph, you know that what's underneath the square root has to be greater than or equal to 0. Subtract 5, x has to be greater than or equal to 0. Questions there? One not done. Example 3, we want to write the equations here, and we are writing the equations of the absolute value of x. So the absolute value of x, that one started right here. So this absolute value was moved what? Right how many?
4.
Right 4, up 3. When we write equations of lines, make sure you write f of x equals or y equals, because if you don't, you'll lose points. I put the f of x equals right here on the line for you. It's the absolute value. Up 3, where does the 3 go? On the outside, it's up, so it's plus 3. Right 4, 4 goes on the inside. If I went right, what sign goes here? What? Subtraction. Okay? If it's inside, you always move the opposite of whatever sign's there. Bless you. Okay. What happened to the parent function on this one? So I reflected over what? Over the x. Then what?
Left 6 down 2.
Left 6. Down 2. So how do I reflect over x-axis? Negative in front. What goes inside? X plus 6. What goes outside? Minus 2. Questions there? So we've talked about moving it right to left, up or down. We've talked about the reflections. The next thing we're going to look at is changing its shape. That is what's called a non-rigid transformation. Vertical horizontal reflections are rigid. These translations only change the position of the graph, not its basic shape. Non-rigid transformation causes a distortion in the shape. means it's going to make that parabola either skinnier or wider. That happens when we put a number in front of the x squared. If the number is greater than 0, it causes what's called a vertical shrink of the graph. Vertical shrink means the graph is going to be narrower, skinnier.
That's a stretch.
Sorry, stretch, vertical stretch. And think about it. If I had a balloon and I did a vertical stretch, what am I doing with that balloon? Stretching it which direction? Vertical is up and down. So if you take the top and the bottom of that balloon and pull on it, what happens to the shape of the balloon? It gets skinnier, doesn't it? And if we do a vertical shrink, so I take that same balloon and I shrink it, I press down from the top and up from the bottom, what happens to that balloon? It gets wider. Or fatter. That happens when I put a fraction, a number between 0 and 1. Not a fraction, just a number between 0 and 1. So if I put 3 halves in front, that's bigger than 1. That's going to be a vertical stretch versus a vertical shrink. Questions? Okay, what I'm looking for you to know is when I take the absolute value of x, that's this right here, and I want to make it dotted. When I put a 2 in front of it, what happens to that graph? It's skinnier. And how, if x was 1, let's do 2. If x is 2, the absolute value of 2 is, and 2 times 2 is 4. So instead of me being up here at 2, 2, I'm up here at 2, 4. Negative 2. So what happens is that number in front of the function, if it's bigger than 1, it causes it to grow faster. You're going to reach higher numbers faster. Whereas if it's 1/2, the 1/2 makes it narrower. Let's go out here to 2. What's the absolute value of 2? What's half of it? 1. So that fraction takes those absolute values and it makes them not quite as fast. Questions? So that's what happens if it's outside the function. What happens if it's inside the function? If it's something like y equals 2x quantity squared, what do you think a horizontal shrink is going to do? Well, what is, if you simplify this, the quantity 2x squared, what if you squared 2x, what do you get? 4x squared. So 4x squared makes it skinnier or wider? Skinnier. So a horizontal shrink. So I have that balloon and I'm shrinking it horizontally, meaning I'm putting my hands on either side of it and I'm shrinking it, I'm pushing it in. What's happening to the balloon? It's getting skinnier or taller. Narrower. And then if I take that 1/2 x, put it inside, again, if you square 1/2, you get 1/4. So instead of multiplying that x squared by 1/2, multiplying by 4, it's going to make it wider. And if you take that balloon, you grab a hold of the sides, and you stretch it, you're making it fatter, right? So 2x squared here's the parent function. And we know it's going to be narrower. Let's just plug in 1 and see what happens. Well, 2 times 1 is, and 2 squared is 4. So 1, instead of going up 1, I'm going up 4. -1, same thing. So see how it's going to grow faster? Oh, let's see, what number do I want to plug in here? Let's plug in 2. So what's 1/2 times 2? 1. 1 squared is, so I go over 2, up 1. And you can see I'm getting wider. So what am I looking for when you graph these? I'm looking for you, when we're looking at the shape of it, put the paragraph there in dotted lines. And I'm looking for you just to show me that you know that it's wider or skinnier. Questions?